Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
This is part two of a two-part discussion with Jonathan Evans from Tzannes and Karl-Heinz Weiss from Lendlease. In this part of the discussion, we discuss how to break new ground and innovate in both engineering and architecture, the lessons learned from all their previous projects that they're going to take into C1, the flow from a digital model to physical fabrication and then to construction of building elements, and the importance of sustainability and reducing embodied carbon for our buildings. So if you haven't listened to part one yet, I suggest that you go back and listen to that first before jumping into this. And if you already have, I hope you guys enjoyed part one. And without any further ado, here is part two of our discussion. Absolutely. One of the things I'm really interested in as an engineer, and you can take this in the context of architecture, traditionally when I do a design, I've got a background in concrete, you go to the Australian standards and you look up the code and it's kind of laid out for you step by step. So when you're doing these really new design and innovative buildings, where do you start and what kind of, how do you go about the design?
You probably, as an engineer, you have to not start from scratch, but take a first principles approach. You want to understand the material characteristics to start with. You do not want to look up straight away span tables and start with the formulas. You want to understand a material inside out, and you want to understand not only how to design, but how it's being manufactured. What's the process behind? You look into exemplar buildings, and that's what we have been doing back in 2005. We've been shipping every week people from the UK over to Central Europe, to Austria, to Switzerland. Well, actually, timber structures have been there for centuries. You find timber buildings built in around the 1200s, and they're still all standing. So you try to learn and educate yourself as much as you can, because I think that's the best approach anyway to a very good design outcome. So if you just look at span tables, at a certain point you don't know what you're doing.
Yeah, architects love to get very intimate with the materials that we work with. So similarly, I hopped on the plane and went to Austria, the centre of CLT and glulam, and basically followed the whole supply chain from the forests, looking at the different methods of the sustainable forestry in Austria, and then through the whole CLT factory and the glulam factories and the CNC machineries, just to sort of investigate what capacity these things had, like how they were constructed and what the engineering was behind the raw materials. And then when we came back to design in Shasha House, we really just approached it with a very open mind. Again, it was very easy because there weren't any other examples to sort of follow, so there wasn't any business as usual. So we started with a very large matrix, looking at all the different aspects from its weight, the number of elements, which then meant the number of crane lifts, the connections, the surface area exposed to fire, all of those kind of aspects, and each one had different pros and cons. So it's really just working through that. If we did this design, then we had more lifts, but less volume of timber, for instance. So it was very engaging. And because the structure, again, is the architecture, it was very much a collaboration with the engineers and the architects. It wasn't just, here's the building, dear engineer, go away and size it up for us kind of thing. It was very much a collaboration and looking at the lateral stability of the building. Again, concrete, you just stick it all in the core and that's done, game over. The timber, we had to look at, how are we going to provide the lateral stability of this? And are we going to make it a feature of the building, which we ended up doing, in the K-braces on the perimeter? So we integrated, again, the structural requirements of the building as part of the character of the building, and let timber be the hero of the structure rather than trying to compete with a a fancy facade or a tricky form. It was really just utilising timber, representing its sort of load paths and using it to its maximum. So everything in that building is timber above the ground floor, the roof, the walls, the lift shafts, even the emergency fire stairs are 100% timber construction. So it's really just looking at each element individually, and the best design solution that included the architecture and the structural and the fire loading and the acoustics and all of the technical issues coming together.
I think collaboration is actually essential. So without collaboration in that space, you can't push the boundaries, and you're not achieving actually a well-coordinated outcome. So architects and engineers have to sit around the table. Very important. Obviously, I've been exposed to some teaching experiences in the past, and going back to Germany, normally it's already inherent in the teaching process that engineers from an architect's perspective, engineers over designing. From an engineer's perspective, architects have got no idea about structure. So I think it's important that actually both moving together closer again to really achieve an optimum outcome, and sharing actually across both disciplines. And this is not only for engineers, this includes, and architects, this includes actually services coordination, facade, every single trade. And we see actually the best examples are based on, or the best buildings are based on a strong collaboration model.
Yeah, it sounds like this culture of teamwork needs to be at the very front of every project that you've been a part of to be successful. Yeah,
it actually goes beyond that. It goes to the delivery team as well, because the key to the success is the speed of construction on site. So the delivery team needs to be involved and start looking at crane locations and areas, like site areas where they can lift from and deliver the panels to, and how many lifts per day is achievable, and how soon the facade can follow along the timber. So early involvement with the contractor, in this case Lendlease, is really important to that success and maximising the benefits of the timber construction.
So which means that timber structures in execution are actually a logistics exercise.
Yeah.
So they're no longer a typical builder's package where you rock up with your tools. It's really a pure assembly process with an instruction manual, ideally.
Yeah. And that means that everything is resolved in the digital world. Like we took this building a lot further than we do our concrete buildings. Simply, so everything is pre-planned. Every connection is pre-considered. All of the program is thought out before delivery. Every service path has a designated route through the building. And concrete buildings tend to get a bit lazy because everyone goes, I know how to do that. So you just leave a zone for all the services and they sort of sort it out on site, but that leads to inefficiency and waste and clashes on site that have to get unwound and RFIs, and it's not the ideal and certainly not the most sustainable or efficient or safe way to build. But if you can resolve all of that in the digital world, have it fully resolved, fully planned before it arrives on site, everything goes so smooth compared.
So how's the workflow between 3D models and from that to the manufacturing plant that Lendlease have?
Obviously, we completely reliant on a 100% accurate 3D model to start with, and I think there's still a bit of an educational process. From there, we generate our CAM files. So that's an important part, that you don't have got any interruption or interference once the model is done. In the CAD software, then it flows automatically into the CAM world. and it's then translated into machining files.
So it's really the single file that we initiate at DA stage. It starts off quite crude, and then that single model gets developed, and then it gets split to the consultants, like the structural engineers and the service engineers are all producing the same models that go into the one. And again, this single model continues, like Karl-Heinz said, to the factory. So it doesn't rely on going back to 2D and plans, and then other companies or subcontractors sort of recreating what's already happened. So it's really the BIM dream that we've been waiting for that hasn't really eventuated, but it relies on that sort of continuous collaboration and integration and federation of the models to provide that accuracy and consistency.
Yeah, I think there's still a mountain to climb. I think we're on a good pathway, and this has to do with, especially with the coordination and the collaboration space, because you have to coordinate all the penetrations, and they should go into the model. They should go into the model in the right place and the right diameter, etc. Because you want to drive the fabrication through that. That's one aspect. Probably 3D models have been in the past predominantly used for visualization of building, creating nice photos and renders. Meanwhile, the level of information in the model is substantially increasing on a daily basis, you could say. And I think even the software industry will have to adjust quite big time, because models become so big in terms of data that they're hard to handle. And currently, the current BIM software aspects don't allow for deep manufacturing. So there is another workflow from the model where you go into the CAM space. The other aspect we have to take into account, obviously, sequencing. Because once you have got the manufacturing file, you have to then look into which panel is going to leave the factory first, and which one leaves at last on a daily base, on a delivery base, and then go backwards actually from the demand on the side and schedule the whole manufacturing side of things. So there's a level of complexity, again requires collaboration, because you have to agree the sequence on site, which is driving everything backwards.
One of the exciting projects you've got coming up is C1, which is the big sister, so to speak, of International House.
Yep.
What past learnings from previous projects you've had can you take away going into this project?
Oh, there were so many lessons learned on International House. Again, the first time of doing anything takes a lot of pre-planning, a lot of thought, but it doesn't always eventuate. So the lessons learnt have been considerable and a lot of them unexpected. But it's formed a real platform now to sort of launch further. So the ambition with the big sister, it is 50% longer building. It's the same height because that's dictated with the master plan. But as a 50% larger building, the ambition is to build it in the same time frame as C2. So that kind of level of improvements just in the one project. We are, again, taking confidence in what was achieved with International House and taking it further. For instance, the column grid in the first project is a 6 by 9 metre grid, and that's a very efficient CLT span. In the next building, we're pushing that to a 9 by 9 metre grid. Again, first in the world. So we did have a discussion with Lendlease, should we just do a twin sister? Just, we've learnt the lessons, let's just kind of rely on those and just do same again, same, but different. But we thought we're in this such acceleration of learning and innovation, let's keep learning and keep investigating how far timber fabrication can go. And again, this is a step, it's certainly not the end point, and the third sister, again, if there is one, we'll be pushing it again because it really is in its infancy of commercial buildings anyway. And Lendlease and ourselves really thought it important to keep pushing the boundary, go for a larger grid, a different structural system. But again, we pulled out the old matrix and sort of re-investigated number of lifts, volume of timber, foundation weights, number of connections. All of those feeds into the eventual success of the building and the speed of construction and the ultimate cost of the building. So all of that has been taken to the next level, and we see there's still further to go in the efficiencies and just maximising every single benefit of prefabrication has to offer.
Yeah. So if you look into some of the numbers on C1, which is the big sister building, he said it's 50% larger in terms of floor area, but it will be built at the same time frame, which means we have to accelerate productivity quite significantly. And one of the parameters we have been looking into is actually number of components. And a 9x9 grid is actually reducing the number of components. Because you've got a bigger grid, that means that you've got fewer columns and beams. And now we looked into a different floor system as a rib deck instead of just a pure CLT structure, which takes the secondary beams more or less out, and they will be already prefabricated to the slab, attached to the slab, and then brought to site. So there is already quite an improvement and a step change there.
Yeah, so it's really going back to first principles again, even though it could have just been same. We sort of we got round again, teamwork as the group who had delivered the previous building, and sort of went through all of the lessons learned and improvements that were identified as we went, and opportunities that were missed on C2 because they just weren't realised. But having built it, all of those benefits were then recognised and are embedded in the next building, and I'm sure we'll learn more lessons. One of the exciting ones is the lift shafts, as I mentioned, are all timber. But in International House, that's not appreciated. In construction, you could stand at the bottom of a lift shaft and look up 7 stories of timber. However, you walk into the lift and you don't appreciate that. There's only the construction team who's ever seen that. So in the next building, we're actually putting in glass lifts and glass facade to Scotch Row, which is the laneway at the back. So you can actually sort of experience this 7-story shaft of timber walling as you sort of move up and down the building, and even from the outside as a passerby, you can sort of look in and see that sort of quite dramatic element, but also then start to appreciate that this really is a structural timber, authentic building, not just a veneer of timber.
Our latest mantra as a response to timber, it's not about timber, which is a bit of a contradiction. Bit of a contradiction to what we have been discussing earlier, that being exposed to timber is in fact actually providing a positive impact on us as users of buildings and spaces. Saying now it's not about timber means, from our perspective, is actually we want to have a much stronger focus on actually driving productivity. And productivity, in a sense, really starting to appreciate the simplicity timber provides for every single trade. And I always refer back to a very simple example: is putting a screw into a timber slab with a battery drill versus drilling a hole with a hammer drill, and putting a plug in and putting then the screw into the plug as a comparison, and you immediately see actually timber provides a much more efficient environment, and therefore is a great opportunity. So we're embarking on a journey where we really look into every single component which needs to be fixed into a timber structure, and analyze actually productivity gains here. So timber is important because it's the platform, but in a way it's not about timber. So in terms of its expression, so there's a very strong focus on proactivity and step change, because this will have a bigger impact on how the industry can be future-proof in a way, because where we are in cities like Sydney or Melbourne is we struggling with affordability. So we have to put a countermeasure to that problem, and really because there is a growing market, and I think we should not ignore that. There's a growing not only a market, it's a growing demand of affordable living space, and we should find the right response to that. And I think timber can provide a good basis for that. I'm just referring to some recent examples out of Europe, and I'm still well connected to the industry over there. And as we all know, there has been quite a bit of movement in terms of refugees entering in a number of countries, like Germany, taking about 1 million people on, and all these people require housing. And timber and the timber industry have been providing actually extremely interesting examples of a fast delivery pathways, and building actually quite interesting multi-story accommodation for people arriving into these countries. It's both from an economic perspective and from a fast delivery perspective.
Yeah, delivered in flat pack environment.
Yes.
And very simple skills needed to assemble.
Yeah.
Fantastic. And as we wrap it up, Jonathan, what do you think is the future of timber at the moment?
Well, I really think we're just seeing the very start of a new age of timber, again, because of the breadth of benefits. If it was just sustainability benefits, I think we would only see very few projects. If it was just its prefabrication, again, there's benefits, but I think the broad benefits, but not only speed of construction and ease of construction and lightweight materials and simple fabrication methods and sustainability all together really point to a direction that we are just seeing the initial benefits of the use of timber. For me, sustainability is one of its highlights. It's obvious that the planet is warming, and we need to address climate change, and we're not. We've sort of got our heads in the sand, unfortunately. And timber is kind of a stealth way almost of addressing the carbon footprint in the built environment, which constitutes a large percentage of our carbon emissions around the world. Transport is huge. It's starting to be addressed with electric vehicles and battery technology. And I think timber is probably the similar kind of equivalent answer to the built environment, that we do have the ability to grow renewable structural materials in well-managed forests. Those forests absorb carbon dioxide out of the atmosphere and actually lock it into the timber for life, that can then be utilised for these high-value assets of apartment buildings and commercial buildings and schools. So adding real value and then attracting investment to the material, to the forestry, rather than using it as a pulp or a chip kind of low-value raw material, to use it for these valuable assets will hopefully attract investment into forests, so we get more forests, rather than what seems to me a very archaic way of extracting limestone from the ground in a carbon sink and thermally degrading it to produce Portland cement and releasing CO2 into the atmosphere. So I really think all of the other benefits will lead us down the pathway to more and more timber buildings, utilising the other benefits, and sustainability, even if it is a byproduct, I'm happy with that because it's being achieved, and maybe one day we'll recognise that we need to do more for the planet to address climate change.
Definitely. And cement, I read recently, is 8% of the whole world's emissions. And as you said, if buildings become more operationally efficient, maybe the proportion of embodied energy increases. So with that, the focus will start looking at the concrete side of things, and then timber might become more in favour from that sustainability point of view.
Yeah, that's right. And it's a good point. Operational is obviously very important as well. So it's not just the structure, that's one element, but we have to look at the whole building being carbon neutral as the minimum case, carbon neutral, both in construction and in operation. So in International House, it's 6-star Green Star development. There's no air conditioning inside, it's all chill beam technology. The cooling system is heat exchange with the harbour. There's water recycling, very minimal waste. Again, is another benefit of timber construction. There's pretty much zero waste on site. One, because of its prefabrication in the factories, and even the factories use the sawdust and the offcuts as biomass to generate electricity for their own plants and their own equipment. And because of the pre-thought and prefabrication and digital modelling, there's really no other construction waste on site, so it's all heading in the right direction.
If you want to use timber on your next mid-rise project, the Wood Solutions mid-rise team can help out with free professional advice. You can contact me directly at jones@woodsolutions.com.au and I will put you in touch with the right team member. Or there's 44 free technical guides that can be found at the Wood Solutions website. Technical Guide 37 focuses on the steps to deliver a mid-rise timber building, and this is a good place to start. Links to all of this can be found in the show notes.